In this lesson, we're going to be looking at the making salts required practical. And when it comes to the required practicals, it is not just the method you need to be familiar with, you also need to be familiar with the safety precautions and the equipment. So in this case, make sure you familiarise yourself with the fact that the safety precautions are to wear safety goggles, and make sure you familiarise yourself with the correct names of all of the equipment that is going to be used. So the first step in this practical is to measure out our acid. Now in this case we want to make copper sulfate, so we're going to use sulfuric acid. And we're going to measure 40 centimeters cubed into a 100 centimeter cubed beaker. And again, it doesn't need to be precisely 40 centimeters cubed, it could be 50, it could be 60, it could be 25, because it doesn't matter, because the base we are going to add is going to be in excess. But it is important that you do specify a volume. So in this case, 40 centimeters cubed of sulfuric acid into the beaker. We're going to set up the equipment as shown. We're going to have our tripod and gauze with our beaker sat on top of the gauze with a glass rod for stirring. And we're going to gently heat the acid. So we've measured out our acid, pour it into the beaker and gently heat it. And then using a spatula at a time, we're going to add small amounts of our copper oxide. The copper oxide is our base. So remember, we're trying to make copper sulfate, so we need to use sulfuric acid, and we need to use a base that contains copper. So the choices are copper hydroxide, copper oxide, or copper carbonate. But in reality, your only choices are copper oxide and copper carbonate, because copper hydroxide is soluble, which we will come to in a minute why that would make it an unsuitable base. So you want an insoluble base that contains the metal that you're interested in. In this case, we want copper sulfate, so we need an insoluble base that contains copper. Our choices are copper oxide or copper carbonate. In this case, we're using copper oxide. And you're going to add it spatula at a time and stir it with the glass rod. And you're going to continue to add it until it stops disappearing, okay, until it stops reacting. So you're going to keep adding it until it stops reacting and starts to settle at the bottom of the beaker. At that point, you know that it's in excess.
So in order to make crystals of a salt, we need to choose a suitable acid and a suitable base that's going to produce that salt. So in this instance, we want to make copper sulfate. So in order to make copper sulfate, we need sulfuric acid and we need a base that contains copper. So our choices are really copper oxide, copper hydroxide, or copper carbonate. Now, importantly, you can't use any of those three. You can't use copper hydroxide in this case. We need to go for copper oxide or copper carbonate because we need a base that is insoluble, because we need to be able to filter and remove it after it's reacted. So the best bet is to always go for an oxide or a carbonate rather than a hydroxide. So in this case, we're using sulfuric acid and copper oxide, but we could use sulfuric acid and copper carbonate. Both of those would produce the copper sulfate we want, and the base would be insoluble so that we could filter it. So we're going to start off with our sulfuric acid. We want to use approximately 40 to 50 centimeters cubed. It doesn't need to be particularly accurate because we're going to be adding the base in excess, which means that all of our sulfuric acid is going to react anyway. So it doesn't matter if we measure it out particularly accurately, but we want between 40 and 50. And we're going to place that here in this beaker, which is just sat on some gauze on top of a tripod. And then we're going to heat that gently using a Bunsen burner. Okay, now it's really important we're heating gently. We're not trying to boil it, we're not trying to evaporate it, we're just trying to heat it gently. We want that sulfuric acid to be nice and hot. And to that sulfuric acid, we're going to add our base. And importantly, the base is in excess. So we don't need to measure it out. We're just going to keep adding it until it stops reacting. So spatula at a time into the acid, being very careful that we don't let the acid boil. Just stirring it with a stirring rod. And what we're eventually going to see is that solution start to turn a blue color. And some of this black copper oxide will start to settle on the bottom, the unreacted copper oxide. So if we keep adding it, it will keep reacting until all of that sulfuric acid is gone And then what we'll be left with is a nice blue solution of copper sulfate and water, and the unreacted copper oxide, the black copper oxide, starting to settle at the bottom. So the whole time it's still reacting, we want to keep heating, keep stirring, and keep adding our copper oxide. We want to ensure that the copper oxide is absolutely, definitely in excess, and that all of that sulfuric acid has reacted. So while we're just waiting for that, let's have a quick look at the equation. So we've got our sulfuric acid reacting with our copper oxide, producing copper sulfate and water. Now it's the copper sulfate that we want. Now by adding the copper oxide in excess, what we are doing is we're ensuring that all of the sulfuric acid has reacted. So all of the sulfuric acid will have reacted, which means at the end, what we should end up with is copper sulfate in water with the unreacted excess copper oxide. And importantly, the next step is going to be to filter to remove that copper oxide. So once that copper oxide has been removed through filtration, what we're going to be left with is a solution that contains just our copper sulfate and our water. So if we leave that to heat, make sure it's nice and hot, and we've made sure all of the copper is in excess. I'm just going to add one more spatula just to be sure. And what we should start to see is the solution starting to turn blue and the unreacted copper oxide start to settle at the bottom.
So the next step is to remove that unreacted base, that excess copper oxide that we added. So we're going to set up the equipment as shown. We're going to have a conical flask, a funnel, some filter paper, and what we're going to do is we're going to pour our solution through that filter paper. Now remember, at this point that solution no longer contains sulfuric acid because that's all reacted. That was the purpose of adding the base in excess. So now in that solution all you should have is the copper sulfate that you've made in water with some unreacted base, your unreacted copper oxide, which importantly is insoluble, which means you can separate it using filtration. So by pouring your solution through that filter paper, you're going to remove the unreacted copper oxide, meaning that your filtrate collecting in the conical flask will only contain copper sulfate and water.
So now what we have is a solution of copper sulfate in water, and then at the bottom we've got all of that unreacted copper oxide. So in order to get rid of that unreacted copper oxide, we simply need to filter it, which is why we needed to use an insoluble base so that we could go through this step and filter out the unreacted base. So using a conical flask, a funnel and some filter paper, we're just going to filter our solution. Okay, so you can see all of that unreacted copper oxide at the bottom of the beaker. And what we should see is our nice blue solution of copper sulfate and water being collected, and we just need to wait for this to filter. Once it's finished filtering, you'll see that in the filter paper you have the unreacted copper oxide, meaning that in our solution all we have now is copper sulfate and water. So all we need to do now is transfer it to an evaporating dish, ready for the next step.
Finally, you're going to take the filtered solution from step 2 and you're going to pour it into an evaporating basin, and you're going to use a water bath to saturate the solution. Now, ordinarily you would just heat it directly, but we don't want to evaporate all of the water, so we're using the water bath so that we can control how much of the water is being evaporated rather than heating it directly. So we're just going to use a beaker of boiling water, and then we're going to place our evaporating basin on top of that beaker. And what we're trying to achieve is we want to saturate our solution. We want to make sure we've got the maximum amount of our copper sulfate dissolved in that solution. And we're going to do that by heating it up and evaporating some, but not all, of the water. And what we're looking for is for our solution to go a darker shade of blue, and we might see some crystals start to form on the outside of the evaporating basin. At that point, we know it's saturated and we can turn off the heat. And then finally, we take our evaporating dish and we leave it to cool slowly, and the crystals will form over time. This may take 1 to 2 days.
So the last thing we need to do is to make sure that our solution is saturated, which means we've got the absolute maximum amount of copper sulfate dissolved into the solution. And the easiest way to do that is to heat it. Now, importantly, we don't want to evaporate the water, so we're not going to heat it directly. So instead, I've got a water bath here with some boiling water, and I'm going to place my evaporating dish onto the top there. And what that will do is it will heat it up so that more copper sulfate can dissolve. Some of the water would evaporate, but importantly not all of it. And what we are waiting to see is we're waiting for this solution to go a darker shade of blue, and we're going to perhaps see some formation of some solid crystals just around the edge, and at that point we know it's saturated and we know we can turn off the heat. And once the solution's gone that much deeper shade of blue and we can see some solid crystals starting to form on the outside of the evaporating dish, we know now that it's saturated and it is time to turn off the heat. Finally, all that's left is to leave it somewhere to cool down slowly, and the crystals will start to form.
So this method can be summarized quite succinctly if you think about it in the different stages at which we went through. The first thing is identifying a suitable acid. Now remember, depending on the salt you want to produce, you need to choose a suitable acid. So the first step is always going to be to measure out a fixed volume of the particular acid and to heat it gently. Now the volume doesn't matter. You don't have to remember 50, you don't have to remember 40, which is what we did in the practical, as long as it's a reasonable value, but it is always best to give a value. So make a decision, is it going to be 50, 60, maybe even 100, as long as it's a reasonable number, but make sure you give a value. And make sure you choose the correct acid. If you're trying to make copper sulfate, you must use sulfuric acid. If you were trying to make copper nitrate, you must use nitric acid. If you were trying to make copper chloride, you must use hydrochloric acid. Make sure you use the correct acid, but other than that, you're going to add a fixed volume of it to a beaker and heat it gently. The second step is to add the correct base. So again, if I wanted copper sulfate, I need a base that contains copper. If I wanted to make magnesium sulfate, I would need a base that contains magnesium. If I wanted to make lithium sulfate, I would need a base that contains lithium. So your best bet for your base is to use either an oxide or a carbonate of the metal that you want to be in your salt. So if I was trying to make strontium chloride, I would use strontium oxide as my base and hydrochloric acid as my acid. But once you've got your correct base, you're just going to add it to the beaker in excess, excess meaning more than is needed, okay, to make sure all of the acid reacts. So we're going to add it in excess, and then we're going to filter the solution. The third step, heat the solution until saturated, and finally leave to cool and crystals will form. If you were to write this method exactly and all you were to change is what is in red and what is blue, you can write the method for obtaining crystals of any salt as long as you get the correct acid and the correct base. And the words that have been put in bold and underlined, they are the key terms that you must include in your method. But pretty much this 4-step method will allow you to get 6 marks on any method question you might be asked about recrystallization or making salts. So the question here is to write a method for making crystals of potassium nitrate. Now, in the question, they might not necessarily mention recrystallization. They probably won't make a point of telling you it's the required practical, but the giveaway here is they've said crystals. So we must know it's the recrystallization method. So in the top right, I've put our summarized method, and we're going to use that to construct the method for this particular crystal. So we want to make potassium nitrate. So the first thing is I'm going to add 50 centimeters cubed of nitric acid, because I want potassium nitrate, to a beaker and heat gently. The second step, I need a suitable base. Well, I want potassium nitrate, so I'm going to add potassium oxide. I could alternatively add potassium carbonate to the beaker, and again in excess, and then filter the solution. And then the last two steps are the same no matter what. I'm going to heat the solution until saturated and leave to cool, and crystals will form. If this was the question you were asked in your GCSE and you gave that answer, you would get 6 marks. Again, a very similar question, this time magnesium chloride. We're going to use our summarized method, again shown in the top right. So I want to make crystals of magnesium chloride. They've said the word crystals. I know they're talking about recrystallization. So the first step is to use a suitable acid. I want magnesium chloride, so I'm going to add 50 centimeters cubed of hydrochloric acid to a beaker and heat gently. If I want to make magnesium chloride, I need a base that contains magnesium, so I'm going to add magnesium oxide to the beaker in excess and filter the solution. Alternatively, I could have used magnesium carbonate, that would have worked as well. And then the last two steps, heat the solution until saturated, leave to cool, and crystals will form. And again, that would get you the full 6 marks for this question. So here we have an exam question from the GCSE. So a student plans a method to prepare pure crystals of copper sulfate. Now they've said the word crystals, so you know it's a recrystallization question. The student's method is add 1 spatula of calcium carbonate to dilute hydrochloric acid in a beaker. When the fizzing stops, heat the solution with a Bunsen burner until all the liquid is gone. The method contains several errors and does not produce copper sulfate crystals. Explain the improvements the student should make to the method so that pure crystals of copper sulfate are produced. So the first thing, they want to make copper sulfate. So what would you need to make copper sulfate? Well, you would need sulfuric acid and a base that contains carbonate. And they've used neither. They're using the wrong base and the wrong acid. So the first thing I would say, the student should use sulfuric acid instead of hydrochloric acid. And the second thing I would say is the student should use copper carbonate or copper oxide instead of calcium carbonate. Those are two big errors straight away. Also, they've only added 1 spatula of calcium carbonate. You need to make sure that the base is in excess. So the student should add the copper carbonate in excess. And then there's no mention of removing that excess copper carbonate. They should then filter it to remove that excess copper carbonate or that excess base. Also, when they heated it until all the liquid is gone. We know that you should heat the solution until saturated. You shouldn't evaporate all of the water. And finally, the student has not left it to cool and for crystals to form. We know the method. We should know those 4 steps. You add the acid and you heat it gently. You add the base in excess and then you filter it. You heat it until saturated and then you leave it to cool and crystals to form. So by using your knowledge of the method and by using your knowledge of the neutralization reaction required to make copper sulfate, this should have been quite an easy 6 marks to obtain. And these are 7 things that I would have pointed out that were wrong with the method. You wouldn't have needed all 7, but these are the ones that obviously stood out as being the things you should be bringing up in your answer.